We spend an enormous amount of energy trying to share our lives online, but the mechanics of sharing often destroy the experience we're capturing. You see something incredible happen 50 feet away. To document it, you look away, dig into a tight pocket, and retrieve a piece of glass. Next comes the sequence of friction. You authenticate with your face, swipe to the camera app, pinch the screen to digital zoom, and hunt for the shutter button. By the time your lens is focused, the street performer has landed. The crowd has scattered. The moment is gone. We are stuck in a behavioral zero-sum game. Traditional hardware forces us to choose between fully inhabiting a moment and capturing it for our feeds. We rarely get to do both. A new smart glasses technology called long-range gaze eliminates that choice entirely. It turns your natural sight into a primary digital interface, requiring absolutely zero voice commands or hand gestures. Look at this interaction map. Conventional smart glasses track gestures or focus points only within a few feet. Long-range gaze bypasses that bubble. It registers visual attention and projects an interaction vector outward, locking onto subjects hundreds of feet away. If a small object catches your eye across a plaza, you simply look at it. There is no pointing, no tapping, and no artificial menus to navigate. Distance ceases to be an obstacle. If you can clearly see a physical object, you have already selected it. Imagine spotting a rare bird landing high up in the tree canopy. The moment your eyes fixate on the subject, instant object intelligence takes over. Within milliseconds, the system identifies the specific object occupying your attention. This diagnostic interface shows how the software maps the subject. It instantly surrounds the target with contextual data and identification metrics directly within your field of view. As you hold your focus, the system employs adaptive smart capture. It analyzes how long you look and factors in the surrounding environment to calculate your intent. Once it confirms you are tracking a point of interest, it automatically triggers high-resolution image or video capture. You never lift a finger. By stripping away the physical shutter button, the entire mechanical lag of photography disappears. The visual memory is secured the exact moment you recognize it. Once captured, that visual data can flow instantly to remote colleagues or social network feeds. But zero-friction broadcasting introduces massive liabilities. A live street scene naturally captures unconsenting bystanders, license plates, or proprietary information in the background. Look at this structural breakdown of the filtering process. Before data leaves the device, privacy-aware filtering scans the full visual plane, keeping the primary subject sharp while isolating sensitive secondary elements. The software applies targeted masking. Only the sanitized file passes the outbound checkpoint. It creates a closed loop of security. You get the speed of instantaneous sharing, fully constrained by automated privacy protection. Let's return to the physical world. Another fleeting event happens right in front of you. You watch it happen. That is the entire process. While you observe, the hardware targets the subject, calculates the context, captures the frame, and distributes the file. Your physical connection to the event remains entirely intact. You do not break eye contact. You do not look down at a screen. Human sight has always been a mechanism for taking the world in. Now it operates as a sophisticated control system for engaging with digital networks. The days of missing the moment to document the moment are ending. We can stay fully present in our physical reality while using our attention to look farther, know instantly, and share naturally.